Okay, guys, back for the second half of our study guide. What is a solstice? Is a day when the Earth's rotation axis is most toward or away. Most toward or away from the sun. How do the lengths of day contrast for the summer solstice and the winter solstice? The summer solstice is the longest daylight day of the year, and the sun appears highest in the sky. The winter solstice is the shortest day of the year, and the sun appears lowest in the sky. Important you know that. What is an equinox? A day when Earth's rotation axis is leaning along Earth's orbit, neither toward nor away. So we're kind of just right in this area here is going to be our equinox. We're approaching that. How do the lengths of daylight hours and nighttime hours everywhere on Earth compare on an equinox? Day and night hours are equal. 12 hours daylight, 12 hours darkness equal equinox. How does the tilt of Earth on its rotation axis relate to the change of seasons? Well, that tilt here, that is absolutely the reason for the season. If we did not have a tilt of our axis as we went on our revolution around the sun, we would have the same season year round. So the tilt of the Earth's axis combined with the Earth's motion around the sun, so the tilt of the Earth's axis and the revolution around the sun is what causes the seasons to change. When tilted toward the sun, the hemisphere receives more direct sunlight, resulting in longer days, shorter nights, warmer temperature, because we're tilted toward at that point. Sunlight hits the equator directly and becomes more spread out as you move away from the equator. Since the Earth is round, when the sun is going to hit directly, and so around the equator, so that's why in the Caribbean it's pretty much warm year round, because it's receiving those direct sunlight all the time, regardless if we're tilted toward or away. But then after that, it's more indirect as the sun rays travel along the curve of the Earth's surface. Sunlight hits the equator directly and becomes more spread out as you move away from the equator. That's important to know. It's going to become more spread out as you move away from the equator. The regions near the poles are colder because they receive less energy than regions near the equator. That makes sense. Remember, the northern hemisphere and southern hemisphere have opposite seasons. So be careful when you have questions like that. If it is summer in the northern hemisphere, it's going to be winter in the southern hemisphere. If it is spring in the southern hemisphere, it's going to be fall in the northern hemisphere. So pay attention to how questions might be worded with that. So opposite. So we have our eclipses. So you were to draw the position of the sun and the earth and the moon in a solar eclipse. So with a solar eclipse, we are looking at the sun. Well, actually, really not looking at the sun, because we would have to wear those protective eyeglasses or we would burn our retinas. But we're looking at what is being covered up. And in a solar eclipse, the moon, due to its proximity to us, when it's all lined up perfectly lined up on the correct plane, it has the ability to cover up the sun. So in a solar eclipse, the moon moves between the sun and earth, casting a shadow on earth. So let's go ahead and get rid of that. It's going to have a really little shadow, isn't it? Because of the fact that it is a little object. The moon and the earth, they cast shadows because they're opaque. And so most of the time, these shadows that are being cast by the moon and the earth don't interact with each other at all, okay? It's either a little bit above or a little bit below. But every so often, when everything lines up perfectly, we will have the shadow that's being created by the moon be able to land right on the earth. So the really small dark area is going to be the umbra. So a total solar eclipse can be seen only by people in the moon's umbra. That's the darkest part of the shadow. Think about what we did when we did those illustrations. The darkest part of the shadow is the umbra. That's where you have a total solar eclipse or a total lunar eclipse. Only the people inside that umbra can see the eclipse. If you are way up here or way down here or on this side, nope, you're out of luck. Okay, so it only is going to occur during a new moon because here what's happening is that the sun is shining on that side, so we don't see that half that is facing us. That's the new moon phase. The longest solar eclipse that has lasted is about 7 minutes. Okay, so then we've got ourselves a lunar eclipse. So what is being covered up is going to be, so what is it we're going to look at here is going to be the moon. So once again, the earth is casting a shadow, the moon is casting a shadow, and as the moon orbits the earth, it will be absolutely perfect where the moon moves into Earth's shadow. So in a lunar eclipse, the earth moves between the sun and the moon, casting a shadow on the moon. A lunar eclipse only occurs during the full moon phase of the moon. You can still see the moon during a total lunar eclipse because the Earth's atmosphere is going to deflect some sunlight into the Earth's umbra. Lunar eclipses don't occur every month because the moon's orbit is slightly above or below the Earth's penumbra, so it's not on the same plane. We'll give ourselves a nice reddish orangish tint, and that is because of this sunlight being deflected here into the umbra. So think about your drawing that you did with your solar and lunar eclipse. Okay, moon phases. All right, so you're going to need to identify moon phases. One thing I want you to pay attention to when you look at pictures, is you will have to do this. You are looking for the light. If it's on the right, it's waxing. If it's on the left, it's waning. Right? So here's our light right here, guys. Light, 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 light. So we're paying attention to the light. Okay, so new moon. Can't see any of it from Earth because the side that's being lit, the half that's being lit, is faced away from us. So few days later, because it's going to go counterclockwise, a few days later, a little bit we're able to see. Less than half, crescent. Waxing, light on the right. Wax on, wane off. Wax on, wane off. Okay, first quarter. I know it's the first quarter because the light is on the right, so I know that's waxing phase. Waxing gibbous. Okay, so it's more than 50%, because that would be a quarter. That would be gibbous. So it is bulging. It is, the light is growing. So we're growing on this side, and we are shrinking on this side. The light is shrinking. It's being turned off. On this side, the light is being turned on until we get to a full moon, because the half that's being lit is completely shown to us. So then now we're going to be turning the light off. So it is shrinking. The light is shrinking. So waning gibbous on this side because the light is on the left and it's more than 50%, so it's a gibbous moon. We go to third quarter because we are 3/4 of the way around. Then we have a waning crescent, and then back to a new moon. So wax on, the light is on the right, the light is growing. Waning, wane off, left side, the light is shrinking, and pay attention to the shape. If it is just a sliver or less than half, then it's a crescent. When it is a nice crisp line here, half and half, that's a quarter. And then bulging, that's a gibbous, full moon or new moon. Don't see any of it? Nope. See all of it? Full. So, what I need you to do to study for this is you need to review this video. You need to review your notebook pages. There's a lot of information on those notebook pages that are going to be helpful for you on this test. Make sure you review your vocabulary, the McGraw-Hill definition for your vocabulary. Make sure you practice again with the Kahoot. Make sure you practice again with the quizzes. And I know that you guys are going to rock this because you are awesome. Hope you enjoy this. Study hard, guys.